I'm Jack Oswald, and you're listening.
This is Nathan Hamel, and you're listening to...
I'm Richard C. Hoagland, and you're listening to...
I'm Art Bell, and you're listening to Dr. J Radio Live.
Greetings, ladies and gentlemen, and chaps, as my co-host would say. Welcome back to Dr. J Radio Live, a truly international syndicated show broadcasting on several networks here in the United States and abroad, not to mention terrestrial radio, iTunes, Shoutcast, TuneIn.com, and much, much more. As I said, I am Dr. J in the U.S., specifically in the City of Angels, where it just happens to be 7 p.m. Pacific time. On those of you on the East Coast of the United States, 10 p.m. Eastern time. And don't forget, for where my co-host is, and a lot of people have come from there, questions from that group, those stations, is, of course, London, England, and of course, the United Kingdom, 3 a.m. Greenwich Mean Time. Now, today, we are finally bringing you what you guys have all been asking for, literally been asking for probably since the first interview, a couple years ago, or a few years ago, it was 2 years ago, and basically you guys have asked if he could come back the moment he was off. So I know you guys can't get enough of him, so let me just give you a quick background. There are a lot of visionaries in humanity's history. First of all, you have Leonardo da Vinci. Then we have Nikola Tesla. You have Buckminster Fuller. You have Einstein, even. And there's just so many people. Why? What was so different about them? They were thinking outside the box. They got to break through some physics or some understandings. Some could be physics, some could be science, because science is supposed to be exact art, right? Not theories and hypotheses. However, when you realize that something anomalous is happening, say, around you, like, wait, how's gravity changing, or so on and so forth, then you realize, okay, that can't be right because it doesn't fit in our known physics. However, that's the key. You have to accept the understanding that we may not know all the answers to physics. And who better to bring on than a great friend of mine, an amazing guest. And again, this is our Dr. J Radio Live's show, treat for all you global listeners. I bring to you the founder of the Resonance Science Foundation, the one and only Mr. Nassim Haramein. Nassim, welcome back, my friend.
Hey, Dr. J. It's great to be back. Been a while.
Yeah, absolutely. And it's always a pleasure to host you on the show because you just have so much. And I know we will never, ever get it in the time frame, but hey, that's what we continue shows for. Now, I say this time, let's go to the basics. When did you first start leaning into science and to physics, etc.? I mean, I'm talking about before Foster Gamble stepped in and aided a little bit, because he's a great guest of ours too, comes on fairly regularly. Everybody out there, you'll hear him soon. He's the heir to the Procter & Gamble enterprise, one of the heirs, not to mention the Thrive movie. He's the one that produced it and wrote it, and probably the most memorable person was our guest, Nassim Haramein. So, Nassim, can you tell us, when did you start to look at physics and realize, wait a minute, we could do something more than this?
Well, when I was really young, I was really interested in nature and the structure of our world. I wanted to understand how the natural world worked. I found it really strange that I found myself in the middle of this amazing, highly coherent, highly organized natural setting, and that I was able to observe it. I wanted to know how that was possible, how it got there, and how I got there as well in the middle of it. And so I think my interest started very, very young. When I was about 9, I had some thoughts about dimensions that were contrary to what I was being told at school, what I was being taught, and later on I found out that many other thinkers, visionaries, had the same problems with these concept of dimensions. But at the time when I was 9, it just launched me on a certain way of thinking about things and looking at the world. And eventually that led me to start writing physics.
And let me ask you this, just to set the record straight, because this was mentioned on Art Bell. Now, I have a doctorate not in physics, in law, and I've had a lot of PhDs here. We had the head of astrophysics from Harvard here on this show, but you don't have any formal education in that sense, but yet you've made more progress than anybody. Is that safe to say?
Yes, well, some might disagree with you as far as the progress part, but I definitely did my own path, and I felt like, if I went to institutions for my source of information, I would be restricted by certain constraints in what you're allowed to think of and what you're not allowed to think of, at least right in physics. And what you can study as well. There's a lot of impedance that comes with like being an assistant professor or being a professor, where you have to give courses and all this. I wanted to just do pure research, and very, very you could say at the time certainly it was thought to be an esoteric section of physics, which was unification. Which was generally reserved only for retired professors or, people that had a lot of experience in physics, because to write unification theory, you have to have a very deep, but as well very wide understanding of physics, because you have to combine theories that usually only studied independently. So it really, took a different course for me. It was more viable for me, if I wanted to move very fast, to study independently and just use the university libraries and resources and do my own studies.
Which, honestly, I think that is a far better way to go. There are actually now schools for young children that don't just have linear teaching. They will look at a child and say, okay, this little boy likes math. This little girl likes art. So let's help them in that sense. And I believe that, rather than sticking everybody to go through the same stuff, because not everybody's meant for it, or here's the best part, absorb it. I'm going to give you my own personal example. When I was in school, and all the way, I'm talking about from grade school all the way up to, getting a doctorate and a master's in between, I realized that I really didn't care much of what I was reading about history. I would just read and just take the test and go on. But it's only after I finished that I realized, wait a minute, I want to look at this event again. So I will go back to books that were forced to read that I didn't want to, and now I embrace them because I'm doing it. Is that, wouldn't you agree with that? That's the
Yeah, absolutely. And I think, I actually would go further. I would say that I think, and, I discussed this with my father, which very young, because my father was a child psychologist. He had worked under Piaget. He was Piaget's assistant and director of the Piaget Institute in Geneva at one point, and then director of the child psychology section of the University of Montreal in Montreal for years, and so on. So I had early on, when I was 10, for instance, discussion about education with my father very early on, and we both agreed that kids would learn better if they were learning by project. And so, my father founded project schools where the kids are interested in certain project, and then they are given the resources to study these and come up with all of the things required to accomplish the project, and along the way they learn to write and read and calculate and all this stuff. And I think there would be much more Einsteins in this world and Da Vinci's and and so on if children were really encouraged to deliver their gift, instead of trying to constrain them into very specific studies with very specific, fundamental axioms that have to be accepted by the children right away. I think ideally children would have to agree to the axioms, the fundamental axioms of some theory, for instance, some ideas, and then and if they didn't, then they should be encouraged to show how they could be different, or
Yes.
what is wrong with what is done currently, and that is not the case currently. It's not encouraged. If there is, you must agree, and if you disagree, then you're typically in trouble.
That's right. That's right. And that's pretty much sad, really. If you go against what the mainstream physicists are saying and their journals, then you're an outcast, even though you might have or literally be sitting on a theory that is far better than theirs, and you are much more prone and better to actually proving that theorem as opposed, right?
Yeah, well, it is. It's been seen in history over and over again that there's a certain amount of resistance to new ideas, and certainly if the new ideas come from independent researchers. For instance, if Einstein didn't have Planck back him up, I don't think he would have even got known, and relativity would have probably flew right by history, and would have been missed. So, I mean, Planck really supported Einstein and made it possible for him to be heard. And at the time, the world of physics was much smaller. So, now it's even worse, meaning like there is a lot of good ideas out there. However, they're not being heard very well because there's a certain investment in a way of thinking, and even a significant financial investment in experiments that could be disrupted from new physics.
Agreed. And that's one thing they don't like, to be interrupted. No one wants to spend a couple $100,000, if that's what it takes, if they go to private schools or wherever. It's going to cost you that sort of money and a long time of your life to earn such a degree. And then to be told, hold on a second, sir, you're not doing this right, is sort of an attack for them. They take it personally, right?
Of course, yes. And especially if somebody has spent, 40 years, 50 years, 70 years, developing their own theories, they have, it's difficult to accept somebody else's ideas, especially if you're at the end of your life and so on, feeling like what you've worked on didn't have a meaning, or the meaning of what you worked on is diminished by something else. It's difficult to accept. So it's a very natural and human thing to do. However, when it's institutionalized, that is, the institutions themselves should not function under those, more emotional feelings. The institution should encourage new ideas, because it is truly how we grow and evolve. If there is no new ideas, then we become stagnant. So it's really important to examine everything in details. And it's amazing. The world is changing fast, and people are really catching on to a new way of thinking, and there's an amazing transformation occurring, even in the world. And I'm talking the high spheres of physics. There's physics that's actually finally poking through out there, that is making big change in the way people think.
I'm glad you brought up the fact that you have to introduce new theories, otherwise humanity would literally be stagnant. If that was the case, if we were just sticking on old thoughts, then the world would still be flat, right? And there would be no factories or anything like that. You also mentioned I think you said Einstein got some funding. Nikola Tesla was also funded by Edison for a while, right?
Oh yes, but what I said about Einstein is he got some support from Planck, and it made a big difference in him being able to publish and being able to be heard by the physics community. He didn't get funding from Planck, but yes, Edison supported Tesla until it wasn't his fancy, because some of the stuff that Tesla was doing kind of went against his idea of profit. So, that support can come and go that way as well. But it's critical that a theory is supported academically, but as well financially, because it's very expensive to do research in physics, and certainly if you're going to do experimental research to support a theory, then these experiments can cost a lot, like the Hadron Collider, at $13 billion. And so on.
The Hadron Collider is CERN? Is that what that's the one that's $13 billion?
Yeah,
wow.
So it really is, an expensive endeavor to actually, give experimental support to a theory. And in the case of the new theory that are emerging, however, the exciting thing is the experimental application of these new theories, like all fundamental theories or breakthroughs that happened before, these new theories are bringing new technological developments that are going to completely revolutionize the way we do things on the planet. And those require as well financial support to be able to be brought into the world. So all this, is difficult to achieve in a environment where the institution and the academic world tends to reject any new ideas offhand before actually. When I mean new ideas, I mean new fundamental ideas that disrupt some of the foundational theories we're using now. I'm not talking about, new ways of building on what has been done. I'm talking about a fundamental change of the axioms of physics.
I'm actually glad you brought up the fact that people, for instance, when Edison was funding Tesla discovered the alternating current, and that was in direct competition with Edison's direct current, DC current. Well, what is it we use now? It's AC, alternating current, right? And so this just goes to show that it's sad that this poor guy died penniless, but he had so much information, and then now he's being honored. So I'm glad you brought up earlier that the world is truly changing at a rapid pace. And what makes me even more happy is that you have the support of people to get these ideas out there and to start implementing them. That way, people in, say, mainstream physics, like, say, Michio Kaku or somebody like them, or Neil deGrasse Tyson, right? They do not want to be challenged, and they have the backing of their universities, their networks, everything. And so if they just hear a theory, they're not even going to look at the details of how you got there. They're just going to reject it en masse, like you said. So, with that being said, let's talk about what was one of the first theories you worked on. Was it the unified field theory or something before that?
Yeah, I mean, I always was, aiming for a unified field theory.
Yes.
And what I mean by that is a formal mathematical, unified field theory, not just philosophical or conceptual theory. Along the way, it was obviously very much conceptual at first as I developed the concepts of how it worked. My first approach was very much geometric approach to the structure of space-time, which happens to be very similar to what Einstein did. He did geometrize space-time, and many others, including Newton, many other great thinkers like Pythagoras and Plato, and so on. And all these geometric approach were coming from a deep observation of nature, the natural world, and eventually I developed more formal mathematics to describe the geometry. Interestingly, people don't know, but very much Newton spent a large portion of his earlier years, like some 20 years, studying ancient civilization and temple and the geometry that's found in these civilization and temples. He even learned ancient Hebrew to decode his own text, and he built a replica of the Temple of Solomon, which he believed contained the key to gravity, to the understanding of gravity, and so on. So, I eventually started to write physics more in the terms of the current theory. So I added torque and Coriolis effect to Einstein field equations, and then started to look at the very fine scale of space-time, and found that it was granulate in nature, that information is embedded in space-time in terms of quantum granulates that are very small at the Planck scale, and wrote theories in which I extrapolated what I call the holographic mass, which is the mass of the material world, how it comes to be and how it gets there. And it's very effective. It accounts for mass with 100, very, very high level of accuracy. In fact, more accurate than the standard model by orders of magnitude.
I'm actually really, really glad you brought that up, because I've received thousands on that topic alone, people asking if you could expand on it, to touch base on it, or those who didn't hear you say, Dr. J, can you please ask Mr. Harriman if he can talk about the holographic universe, because that's something new. Even a mainstream Caltech professor who does volcanoes for the most part, even he spoke about the holographic universe. So I could see this finally starting to get accepted. Would you agree with that? And also tell us about anything you can to briefly about this, the holographic uniform.
Yeah, absolutely. The holographic principle was actually written early on by various great physicists, popularized very much by, and actually described in string theory formally by Leonard Susskind and de Hoof. And these people are very well known. They're probably, they considered the best physicists in the academic world today. Susskind is the director of the physics department at Stanford, and de Hoof is the head editor of Foundation of Physics, and so on. And so these people wrote, and this is actually well known. It got a lot of publicity because it had to do with the war between the so-called war between Stephen Hawking and Leonard Susskind about if information is lost when it falls into a black hole or not. And the solution was found and agreed with by Hawking, which conceded the bet that the structure of space-time actually embedded the information on the surface of the black hole, which is called the event horizon, and it was described as a holographic principle. So, and so that the information was not lost, and there was a certain level of entropy associated with this, and they calculated the entropy, and it came out right. So then the holographic principle kind of landed very strongly in the center of at least cosmological mainstream physics. But the holographic principle is based on quantum theory, meaning that there is a quantum effect at the surface of black holes. That means that it's very, very fine, that there's a little bit like tiles that tiles the surface of the event horizon of black holes. And the information that's inside the black hole is represented by the information on these tiles, like a hologram. And from there, they start to ask the question, is our 3D reality a hologram of, a 2D surface of our universe? Like if our universe was a black hole, is the inside then just a holographic representation of a 2D surface of our universe? And that really got more and more supported by experiments that occurred a month ago. Experiments that happened a month ago actually confirmed very strongly the holographic, measurements of background in the universe and so on support the holographic view. So the holographic universe is actually very much mainstream in the way it is described there. It's just that my theory takes it to a different level and shows that, no, the universe cannot project from a two-dimensional plane, because no two-dimensional plane exists in the universe. There's nothing that doesn't have thickness. So that brings us right back to my first instincts when I was 9 years old about dimensions, and that there was an error in our understanding of dimensions.
And speaking of dimensions, we now have mainstream scientists saying that there are up to 11 other dimensions. But looking further, you could see that there's far more than that, right?
Well, that's the thing. There's conceptual issues about the idea of dimensions. The 11-dimension manifold that you are mentioning is a superstring, and it really, is abstract math, and string theory in some 3 decades of investigation and literally hundreds of thousands of physicists working on it, I still not given any experimental or observational proof. So it's very, that's why it's mostly been abandoned. And my opinion is that if a theory requires 11 dimensions and complexity to the point where the result of the theory predicts 10 to the 500 different compactifications, you have a problem in the theory fundamentally. Yeah. And so I actually wrote the theories I wrote in 4D, in 3 dimension of space and 1 dimension of time, and not in any higher dimensions for that reason, because those dimensional manifolds are concepts in a model of man, not direct observation of the universe. the universe does not produce two-dimensional planes. That does not, it does not occur. That's a concept of man. And one of the problems is that we develop models to describe the universe, but then we forget that we've developed a model and assume that the model is the universe. And that's a very big trap you can fall into.
Now, I'm glad you brought this discrepancy up with all these different dimensions that we can have. I mean, that is a very big disparity between 11 and 10 to the 500th. But here's a question that I was asked and answered by somebody else from, actually, you know him. He's on your team, from the Resonance Science Foundation, Mr. William Brown.
Oh, yes.
And the last two times he was on, people were asking about two theories, and I'm hoping you touch on this, because after he responded, then the next question came to me was like, what does Nassim have to say? So the two are singularity and what was the other one? Singularity. Well, let's start with singularity. What do you think about singularity?
Okay. Well, you know, it's a very difficult concept for people. Singularity occurs, and I'm talking physical singularity, just for technical people out there. You know, not mathematical singularity. So singularity occurs when a force goes to infinity, like gravity, as a result of you know, of an Einstein field equation. So when Einstein described gravity, he described it as like the surface of a trampoline curving, or if you put a big ball on it. So if you put a big ball on a trampoline, it starts curving, and you put another ball, you know, near it, it will appear as it is attracted to the big ball because the surface of the trampoline is curved. So the small ball seems to be attracted to the bigger ball, and you know, showing that gravity was not a function of the object itself, but of the fabric of space-time around it, being curved by the energy or the mass of the object. So when he did that, that was a great concept. He wrote the math for it, but he didn't solve it. And then he published it, and a fellow called Carl Schwarzschild found Einstein's paper and then solved what it would look like, you know, as it curved, and if you increase the mass. And then he realized that when you solve the equation, it says that there's masses or there's densities that occur in the middle of the curvature. Like if you think of like a funnel, like in the middle of the funnel where the structure of space-time, the curve could go to infinity, which means that the solution to Einstein field equations is a singularity, is a point of infinite density. And he sent those results to Einstein, and Einstein was really discouraged because he thought that meant that his theory was wrong. But then they found that the curvature away from what could be called the singularity or the black hole is correct. Like we measure that curvature when we measure the way light behaves near a gravitational field in our world, in our universe. And so they found out that the curvature is correct, but they ignored the singularity because they said, well, we're just going to make like that's not happening. And Einstein, even Einstein was like very much against the concept of singularity. And then eventually it got to Wheeler, and Wheeler actually looked at the singularity and started to describe it and describe the boundary in which at which light could not escape the singularity anymore. Meaning, like if you calculate, you know, the funnel, you could say, well, at one point, even a light photon could not escape the curvature because it's so steep in the middle. And that's right. When he started to describe black holes. and like the event horizon of a black hole is where light cannot escape anymore, and that's why it's called a black hole. And
Because of the gravity, right? The intense amount of gravity won't let it escape, right?
exactly, and that gravity is there because of an intense amount of matter concentrated in that region, or energy. Of course, E equals mc squared, so it could be anyone. And so you can. So that was the start of describing black holes. Einstein still didn't believe black holes could exist, and it wasn't.
Boy, was he wrong, though, right?
Well, I think that he disagreed with what the theory was saying about black holes, and I think he was right about that. I think the way we have described black holes is incorrect. I think if he would have had the full picture, he might have, been more agreeable to it. Certainly after the fact that they were, confirmed astrophysically. And so we can see now that there's black holes at the center of all galaxies we observe. There's black holes inside galaxies that are stellar-sized black holes, and so on. And there's quasars that were extremely large, black holes, almost the size of galaxies. And so there's lots of evidence for it now. And I think that if Einstein would have had that information and had the data we have today and the mathematical tools we have today, I think he would have solved unification very quickly. But he didn't. And so that was, a very important part in history. It was the development of singularity, understanding singularity, which is not understood still, because a point of infinite density is nothing that the mainstream scientific theories can deal with. It's very difficult to deal with it, and in general, it's ignored or thought to be not relevant.
I'm glad you brought up this Albert Einstein, because one of the listeners pointed this out to me, I have to say, a couple months ago. Since people have been knowing you're coming on, they sent a link via registering on drjradiolive.com, which essentially said that Albert Einstein died so Nassim Haramein can be born and take us to the next level. I thought that was just fantastic.
That's very nice.
Yeah.
That's very
Now,
nice.
Here's the other question.
I'm very honored.
It's true. You look at the amount of people that comes to you, people in countries that I didn't even think were up to speed on this. Some knew you, but like I said, there's a lot. All four corners of the globe. Whether it be Northern Africa to, of course, I mentioned the UK, Scandinavia, Peru, you name it. It's people are obviously very interested in what you have to say, and they like what you have to say, and they like you as a person because you are a very fantastic, great guy. Not to mention, extremely brilliant.
Oh, thank you.
I wouldn't even say you have to say thanks. It's just the truth. Now, here's the other thing. It was about singularity. Singularity and string theory, those were the two that William Brown, every time he was talking about the resonance beliefs versus the mainstream, people wanted to say, what's Nassim got to say about that? So let's touch on the other one.
On string theory. String theory, I think at the basis has a right axiom, a right conceptual notion. That is that the universe is made up of oscillators that are, oscillating at different frequency, and it's producing our reality. That fundamental concept, I think, is very valid, and and it's so simple and charming that absolutely that's why string theory was so popular with so many students for a long time. I mean, some at least 2 decades. And this was, very attractive from the beginning. The problem is that the formalism under which it's written is extremely complex. And I think it went from the fundamental concept, it went into a direction with the specific math that was utilized to describe the concept that led directly into a dead end. And many physicists tried to warn people about that. I was part of some of these discussions at Georgia Tech very early on and so on. And, people, more seasoned physicists could see how it could be a problem, and but it still went ahead, and string theory really, I think, has a value, but the value of string theory can be written in much simpler form, which, at this point, Leonard Susskind would agree with, because he himself has taken a new direction. And that is, I think, much more valuable. That is, the concepts are correct. The application went in a way that wasn't productive.
Agreed. And one thing that I always really couldn't understand that, because that's not my sort of mind thinking. I love math, believe me. I love math, economics, and the law. But physics is something that I never took onto, although I wish I would have, because it is such an exciting field, and the breakthroughs of this can change humanity for the better forever, literally forever. Now, let me say just one small thing about these theories. The only thing I got the understanding is there was no Big Bang to start this universe. There is a Big Bang that has been going on forever, and one that has probably dozens of them have gone on since we've been on this show, because they're in different dimensions. Would you agree to that?
Right. Okay. So again, as soon as we use the word dimensions, things get a little, squishy, a little, sideways. And so I would agree with your statement if you think of dimensions as different scales, instead of thinking of them as different Cartesian planes. And so we think of, if we think about, like, for instance, the scale of the Earth, and then the scale of the solar system, and then the scale of the galaxy, right? The solar system and the galaxy, you can't see it because it's so teeny, right? You wouldn't see it. It's not even like, showing up. All the stars in the galaxies, most of the stars in the galaxies are much brighter, and they just basically bury our sun. So, but and then imagine the scale of the universe, so like billions and billions of galaxies inside a huge bubble that we could call our universe. I would agree that Big Bangs are continuously occurring. If we said that our universe is in a larger one, which you could think of it as another dimension, but I mean literally dimension in terms of scale, and inside that bigger one, there is, universes the size of ours that are most likely being created continuously, so it's a continuous creation model that doesn't have like necessarily a Big Bang at its beginning. That is, that there's creation that's occurring continuously. For instance, even inside our universe, that there's matter continuously being generated because there's a continuous increase of information in the system, and that's why the universe is growing. And not only is it growing, but it's accelerating as it grows, which is, negentropic in nature. It's counter-entropic. So it really, and interestingly, I'm writing these papers. I have been writing this paper on cosmology for a while. I have not published it yet. I mean, I should get to it, but in it, I do describe this model more rigorously in the formalism. But as I was doing that in 2013, a new paper from Einstein was published. I know that Einstein has not been around for a while.
More than half a decade at least.
Right, but they had lost one of his papers and it was found. And interestingly, that paper was an alternative to the Big Bang model that Einstein had written on, that had a continuous creation model where matter was emerging directly out of the structure of the vacuum, the structure of space-time. Continuously, protons were being made, and the universe was losing protons. And the result was the universe we saw. And it was a very interesting paper, and it's great that I can quote Einstein 2013 in my paper that hopefully I will publish soon.
I know, right? People are going to think, is it 2013 or 1913? It's really big. Anyway, I'm going to say at this moment, everybody, stay tuned. We got so much more with the one and only visionary physicist, globalist, and, of course, futurist, not to mention universalist, if that's a proper word, the one and only Mr. Nassim Haramein. Everybody stay tuned. We will be right back. Welcome back, everybody, to the second half of the incredible interview with the one and only founder of the Resonance Science Foundation, Mr. Nassim Haramein. I've been receiving so many requests from you guys. Even the moment he got off the last time, you are asking more questions and wanting him back soon. Well, ladies and gentlemen, he is here. So, Nassim, before we continue, let's talk about the Academy, your website, and any upcoming laboratories that you're going to fix or retrofit or install or make or anything like that. Where do you see yourself, or what's happening in the next few months, and where do you see yourself in a year, 5 years, etc.?
Well, thank you. Yeah, absolutely. I mean, we have a large community on the the Resonance Academy site, and that's part of the Resonance Science Foundation, and we offer courses. The Delegate Program is our core course. It's a course that addresses unified physics from a layman perspective. Everybody can take it. 10-year-old have taken it, and 80-year-old ladies have taken it. Even one of those ladies did an incredible talk in England at one point as a result. But so there's a great community of people. You get to meet people from all around the world that are studying this stuff, that are thinking about it, that are asking questions. 2 hours a month, I connect with the students, and people can ask me questions. So every month you get to be able to get information directly from me, and the course is very in-depth. You can go as deep as you want into it, or you can stay as light as you want and just get the higher concepts. But it addresses not only unified physics, but as well, biology and consciousness studies and worldviews, the way we view the world and how we interact in it, and ancient civilization. So there's a lot of cool information there for people to tap into. We're about to modify all of that structure as well, so it becomes more readily, easier available for people. So stay tuned for that, and that should be in the next month. And as well, we're setting up to have a great delegate program gathering every year. That's going to be in various places around the world. So that's going to be a lot of fun. So a lot going on. And as well, I run private laboratories where we do experiments to support the theoretical framework that's been written in the Science Foundation. And from there, as well, I have many talks that I give around the world. So it's good to subscribe to the Science Foundation, the Resonance Science Foundation. Like that, you get all the updates of what's going on and what we're doing, because there's a lot going on.
Now, let me ask you this. I hope it's not too personal, but I just want to make it a point because I'm in the midst of this course, thanks to you, and I vouch for it 110%, everybody out there. All you have to do is go to resonance.is Institute, or go to our website, Dr. J Radio Live, drjradiolive.com, and click on the Resonance Academy banner. Now, this is the part that I wanted to mention was personal to you. This course is not limited for people who have IQs of 120 and up. Your children went through this. Am I right?
That's right. That's right. My children and the children of the CEO of the foundation went through it, and others. I meet children from around the world all the time when I give talks that have taken the course. And as well as I was mentioning, some of the senior members of our society are taking the course and really enjoying it. And so, and they're not engineers or physicists or anything like that. We made it so it can be as accessible for people as possible. And like I said, you can go as deep as you want. If you want the really technical stuff, all the references are there, all the information is there, or you can just skip off the surface and just get the fundamental principles and think about it in your spare time.
Agreed. And that's why I only see positive feedback from this. And everybody who comes on my show, a guest, and who is promoting a course or something, books, everybody, most people have books. They send them to me in advance so I could read and just get a gist of what we're going to talk about. I have to say this course is a lot better than a lot of all that I've tried in this realm. Now, I'm not going to say names because I don't want to negate other friends and other guests, but I have to say, all you listeners around the globe, make sure you check the Academy out. It is worth it. Now, Mr. Neherman, let's see if we can go back to something you were talking about. Actually, no, here's a great topic that really needs to be addressed. Basically the organized matter. You have the same energy that's going on in subatomic levels through the human cells, through the human body, through the globe, the weather, through the planet, like I said, the globe, the star system, our solar system, and the way the entire galaxy, and for that matter, other galaxies fit in the same sort of model. Can you explain that?
Right. Meaning that the theory is able to be applied at all scales, so far anyway, that I've been, that we know of. And so that it's been very exciting, because this is something that Einstein was looking for a very long time. I mean, many others as well, trying to unify physics. And people out there may ask, what do you mean by that? Is physics deunified? Well, it's deunified in the math that we have today in the mainstream views. Not that it's deunified in the real universe. The real universe is quite unified, because if it wasn't, we'd be in trouble. And so that's why, and Einstein said, well, it's not appropriate that we have a theory for the big stuff, right? That is relativistic equations, like gravitational equations, and we have the physics for the small stuff, which is quantum theory and quantum mechanics, and that the two don't agree with each other, because obviously big stuff is made out of the small stuff. And so that's unified in the universe, because if it wasn't, the big stuff wouldn't be there, and we wouldn't be there
because
with
it wouldn't be there because all the small stuff wouldn't fit in it, right?
Right, it wouldn't be there neither. Like nothing would be there. So, because when you say small stuff, you're just referring to a scale based on the frame of reference that we observe it from, right? So from our frame, there's smaller stuff and there's bigger stuff. But for instance, from the frame of an ant, the bigger stuff includes you, right? And the smaller stuff, is much smaller than for you. That for you think of the ant as small. The ant doesn't think of itself as small. It just thinks of you as big, right? So when you look at this, like really kind of at a high level, that there's got to be a way that the two are compatible, that the physics of the small stuff and the physics of the big stuff is compatible. It must influence each other in a very fundamental way. And because the small stuff makes up the big stuff. So it really kind of like gives you a sense that and so for many, many years, physicists have been looking for a unified field theory. Einstein worked on it literally till the day he died, like hours before his death. He was trying to solve these equations. And then many other physicists afterwards. But it's, when I started physics, interacting with the physics community in the 80s and 90s, early 90s, I realized that physicists at the time had kind of conceded or resigned themselves that a unified view of physics was not possible. And most physicists, were pretty well disenchanted with the idea and kind of resigned themselves that there's two physics and there's one for the big stuff and one for the small stuff. Even just approaching the subject was discouraged by professors and their students. It was too big. The general idea was, if Einstein didn't figure it out, why would you? And so on.
Yes.
And, so in general, it was poo-pooed to even, claim to be working on unified field theory. But what's not considered there is that, of course, Einstein didn't have the data we have today. Einstein didn't have the tools we have today. There's many things that have changed since Einstein. And,
that's right.
And, I have no doubt that if Einstein was alive today, he would have figured it out. So I at least if he got listened to, because, for a very large part of his life, Einstein was no longer listened to because he disagreed with some of the fundamental axioms of quantum theory. And they just thought that he was not productive after relativity. So it really, maybe he would have figured it out, but would have he got heard would have been another issue.
Probably a century or half century later, right? Like Nikola Tesla. And we don't even know all of it because, according to his niece, as soon as he died, and this is just a little trivial thing to know, if everybody out there knows about Nikola Tesla, but maybe all of you don't know, is that he did everything in threes. So if he had breakfast, 3 pieces of bacon, 3 eggs, and so on and so forth.
Yes.
His rooms, hotel, was always divisible by 3. So that was really meaningful to him. But we only got to see a tiny bit because the precursor to the FBI, if I'm not mistaken. I don't remember what they were called then. And another guest has spoken about this, a professor named Richard Spence. The point being, though, is that his stuff, his notes, were confiscated. So what we're missing so much of his work, and it's pretty sad because now they claim they can't find it. Just go and figure. That's the normal thing. No,
Yes.
let me ask you this.
So yes, go ahead. I mean, I was in.
Finish.
So basically, I wrote you were asking about unification theory, and I wrote a new approach to unifying physics, and I started by modifying Einstein's equations and adding a spin or torque in it, so that space-time wouldn't just curve, but it would curl as well. It would spin like water going down the drain. And I made that the source of the spin of everything, like the spin of the nuclei of an atom, or the spin of a planet or a sun or a galaxy or a universe. And is saying that the source of spin was inside space-time, not just gravity. And that actually spin was more fundamental than gravity, because like the water going down the drain in your tub, if it's not spinning, it's not going to curve. So when it goes down the drain, it curves because it's spinning. And so that kind of led me to describe space-time a little bit differently. And just like the water in your tub, the water is made of smaller constituents, like the molecules of water and the atoms that makes the molecules. And they're all spinning together when they produce that surface that curves. Okay, well, I start to describe space-time like that, made out of smaller constituents that are called Planck oscillators. They're little Planck balls. The reason I call them Planck is because they have a radius equivalent to the Planck length, which is extrapolated from the Planck constant, which is the source, is the fundamental measurement of quantum theory. It was the start of quantum theory, was the Planck constant that was developed by Planck and Max Planck. And so this whole so I started to describe space-time with these little Planck oscillators, and as in the standard model of the holographic universe, I described each little Planck as a little bit of information, and then I start to calculate how many bits of information are on the surface of a black hole and how many bits of information are inside the black hole, and I start to describe how they co-move together, they spin together like this, like the smoothie universe, if you'd like, where the smoothie is space-time, and it's spinning. And when we see a galaxy, it's not spinning because the matter is in it, it's spinning because space-time is spinning, and it's entraining matter around. So it's a different view. It's like there's something we don't see, that's space-time that's spinning, just like your coffee in the morning when you spin it, if there's no milk in it, you can't tell it's spinning. But then if you put milk in it, all of a sudden it makes a little galaxy in there.
You see it.
Yeah.
Yes, that's right. That's right.
So just like that, where the milk is the stars and the dust and the plasma and all this stuff, the radiation that's stuck in the spin, and so you see the galaxy. But if you took all that stuff out, it'd still be spinning, but you wouldn't see it. And so the same thing, like imagine that spin is happening to make a star or to make an atom or a subatomic particle, that it's basically space-time spinning like little vortices at different scales. And so I made calculation on all that, and it started to output many fundamental constants that we measure in the universe, including the mass of matter, the mass of protons, the radius of atoms, the mass of electrons, and all the table of elements. Everything just came out of it, like in a very simple way, considering the mathematical formalism is basic algebra and geometry. And so it really is remarkable. And it gives us a completely different view of the universe, and it unifies the scales because the equation is good whether I apply it to a black hole in the universe or I apply it to a subatomic particle inside an atom.
When I picture how some of this works, and correct my terminology if I'm wrong, but essentially what I see is what uh, Foster Gamble did a great job in actually creating an animation of this energy field where it's like a circle, a globe, three-dimensional, and you have energy going around it and then down the hole in the middle and then back out around it.
Yeah, exactly, like a torus. That's called
torus.
Yeah,
That's
exactly.
what I was going to say. Thank you for, I was on the right word.
Yeah, it's a torus.
I wrote torus down. I wasn't sure if that was the one down. But let's talk about that because that is huge. That is so ultimately important for humanity to understand that, listen, this model fits everything. Right?
Everything we look at, even magnetic fields, like the magnetic field of a magnet is a torus, and the magnetic field and the electromagnetic structure of a star is a torus. In fact, they're dual torus. It's like two torus squished together that makes up a sphere, and because there's Coriolis effect, and that's why I added torque and Coriolis effect to Einstein spacetime to describe this.
His was stagnant, right?
Yeah, exactly. Well, yeah. So that spacetime curves, but it's not spinning, right? So like the objects in spacetime are spinning, but the curvature is not spinning with the objects, and so it's a little different. It's like a soup, like the smoothie universe. And so yeah, just like when you start your smoothie, it makes a torus, right? And if the Vitamix you were using had a round container instead of a square one, it would be like more the right geometry to describe it, but you'd have those toruses. And this is what you see like in galaxies, for instance. You see the equator, where a lot of matter is squished between two very large torus that have the vortices at the center of the black hole, in the center of the galaxy, coming up, creating the top of the torus, and then you can see the star. We actually know that stars go from the equator along, what's called the galactic halo, which is a big sphere around the galaxy, and then they end up at the pole, and then they come back down towards the middle and then back out at the equator. So we can actually see those torus dynamic at very large scales. And now there's evidence from the background radiation of the universe that the universe is a torus, and so on. So it's kind of torus all the way up, all the way down.
I don't want to mispronounce her last name, so I'm just going to say the physicist Elizabeth. You did some work with her. What's her last name? Pronounce it correctly for me.
Rauscher. Elizabeth Rauscher.
That's right. Yes. So you have the Harriman-Rauscher metric, and of course that's the new solution Einstein's field equations that incorporates torque and Coriolis effect, right?
Correct.
In a structured vacuum.
Yeah, in a structured vacuum, exactly. What we showed is that space-time, even just like from plasma dynamics on star and all this, you can tell that space-time must be structured and polarized. And Dr. J, we wrote this some 15 years ago, and just recently, like a few months ago, they were able to look at the behavior of light near very strong electromagnetic and magnetic and gravitational fields near pulsars, and they can see that space-time must be structured because of the behavior of light. So this is the first time it's actually, well, it was confirmed before, but it was not necessarily accepted. Now these measurements are very, very strong, and showing that basically the space between you and me and the space between everything in the universe is not empty, but it actually is full of an energy, and that energy is not just chaotic, but in certain circumstances is highly coherent, like a crystal. Like basically the light that comes off in those regions is polarized just like a crystal would polarize it. It's called bifrangian. And it really, it shows that like basically space-time can act like a crystal. And it's very, very exciting that they are able to measure it now.
Well, earlier when you were talking about the scaling law for organized matter, was that something you did with Miss Rochester?
Roscher. Yeah.
Roscher.
Yeah. Well, we wrote all these papers together. She helped me with the formalism for these equations, and then the scaling law. Basically, we were showing it's like a different scale are related in the universe. It's not all random. That there's fundamental, and to prove that space-time must be structured, that there's some kind of pattern that you can find in the universe, and the patterns between the different scales. There's other patterns you can find, for instance, on biological structures all around us on our planet. We see a lot of structure. And you got to wonder, where is that structure coming from? Where is that organization coming from? And we were showing that it's coming from space-time itself, meaning that matter is obeying something that is more fundamental that we don't know is there, or that we don't measure very well. We measure it just in terms of its gravity, but we don't know how it works. That's why if you ask even a mainstream physicist today, do we know what gravity is? If they're honest and actually know their physics well, they will tell you, we actually don't know what gravity is. We just know, as described by Einstein, that it's curvature in space-time, but Einstein didn't say what is space-time specifically. What is space? Like, is it something? Is it does it act like a fluid? Does it act like gas? How is it? How does it act? And all this. We know it curves, and it creates physical effects that we call gravity. But
yes.
But now we're just starting, and with this theory and other theory, to actually understand its structure, because it was thought that it would be completely random, and it's not so, because there's spin, and when there's spin, there's polarity. When there's polarity, there's organization.
Let me ask you a quick question about Elizabeth Roscher. Is she a fairly well-known physicist that has a PhD that is accepted in the communities?
Oh, yes.
But, okay, so she got some backlash when she introduced this new information.
Oh, yes. Well, Ms. Roscher received a lot of backlash pretty well all along in her career. She actually has some of the best credentials you can get in physics. And she taught for many, many years. She was an excellent professor. She wrote physics that deserved Nobel Prizes, but that were passed because she's a woman in physics, which at the time there was only very little of them. So it's not the first time that she gets back, some not so great feedback from the industry. I mean, her contribution to plasma physics early on was very significant. Her contribution to saving quantum theory early on was very significant. A book was written about the hippies in Berkeley that were physicists, that saved quantum theory. And she had started that group with other physicists to find solution to, at the time, what was a crisis in quantum theory. So, I mean, she wrote some very significant papers, over 300 different publications, encyclopedias in physics, and so on. So, encyclopedia articles in physics. So, it really, she knows her stuff, and it was great to be able to collaborate with her. I collaborate as well with an astrophysicist now, Dr. Val Baker from England.
Mm-hmm.
I collaborate with other physicists that I have not finished writing papers with, but other physicists are now, people with PhD and so on that are now like coming to help, because of course,
Yes.
It gets overwhelming when you're trying to describe all this in mathematics, and I can't just do the job by myself.
But the fact that you have mainstream physicists hopping on board and looking at it instead of just dismissing it is a really positive thing. I think in 10, 15 years from now, your science may be accepted. And I'm glad you mentioned the Nobel Prize. I was going to save that for last. I could see that happening in the next decade or two, getting a Nobel Prize when you break through. Now, here is the big question, my friend. I received no less than 10,000 plus, maybe even closer to 15, maybe 18,000 questions, all about this one topic. We brought it up already. Gravity. Does humanity have the ability to alter gravity as was portrayed in the movie Interstellar?
Yes. This is a very big part of what I've been investigating all this for very early on, even when I was a kid. My thought was, well, if I come up with a better theory, then it has to lead to something practical. Otherwise, it's a waste of time. And for me, it was really important. And of course, if we understand gravity better, then we will understand how to control it. Just as when we understood the electromagnetic field better, with some of the work that was done by Maxwell and some of the work that was done by Faraday, we started to be able to apply it, and that led to pretty well everything we do today. I mean, including, of course, the computers, the cell phones, everything. I mean, everything in our life, the electric fields, the magnetic fields that are required to fire the pistons in your car engine, the way you're lighting up your house, the way you are heating it up, everything is a result of us understanding the electromagnetic field and learning how to control it and to direct it in certain ways that it can run our devices. Now humanity is getting to the next level of understanding, where we are actually starting to understand gravity at its more fundamental level, at its most fundamental level. And as we do, of course, technological application is very much possible. And I believe we will be controlling gravitational fields in the next decade. In fact, there is already, for instance, there's an EM drive out there, which is from a physicist from England that just found that by bouncing microwaves in a can, in a conic can that's plugged on both ends, creates like a torus inside it that produce motivation. It produced thrusts, and it's not pushing against anything that is conventional. So it took him something like 10 years to get any other lab to even consider testing it, because everybody said it was impossible because it violated the laws of motion, because it's not pushing against anything.
Or should you say there are theories of violating Wishing, right? Because
That's right.
obviously you could prove them incorrect.
Right. Well, actually, I think they're still correct. It's just that it's the drive is pushing against something that is unknown. It's pushing against the vacuum. And that's what NASA, which finally eventually tested it and retested it, has come up with, that it's pushing against the fluctuations of the vacuum in the structure of spacetime. And so that's very exciting, because that's another thing that supports the physics I've been writing. And so we're already there. We're very, very close. We're very close to gravitational control. And I don't like to use the terminology anti-gravity, because that'd be like calling, light
Yeah, anti-light, anti-dark. Yeah, exactly.
So I'd rather use gravitational control, and basically that's really what it is. And basically you're just directing the gravitational field the way you want it, so that instead of getting sucked up to the planet, maybe you're getting accelerated towards the sun, or you're getting accelerated towards another gravitational field, or accelerated all together, against the structure of space-time itself, which is what that EM drive seems to be able to demonstrate. So, it really is very close. It's not decades from now. It's not like 3 generations from now. It's our generation that will see this new level of technology emerge, if it is allowed, if it's led that way, if it's supported, if the financial structure and the political structure allow it to emerge.
Exactly. And I'm glad we're on this topic, because some of the other questions, again, like I told you off air, I don't want to say it on air, but the amount of people that were asking things or commenting on things, the implications of having the ability to control gravity, that means that we can build something that could bend space-time, and hence put us faster than light speed, right? You're not going in a straight line from point A to B. You're going to fold the space-time fabric, and pretty much puncture a hole and get to it, right?
Right, exactly. So of course, initially you would just fold space-time or curve space-time a little bit. You can control how much you're curving it. Just so the listeners out there understand, this is not like completely outside the mainstream neither. Like there is an agency at NASA trying to produce a warp drive today, and so many laboratories around the world are working on this. But if you can think of it as, so initially you would curve space-time a little bit just so you can get levitation happening or acceleration towards the moon, or so that we can visit our local solar system readily. And eventually you could curve space-time more and more till you got it to create what is known as a wormhole. And
Einstein-Rosen bridge.
Exactly. And these wormholes, they thought, until recently, people thought they were very exotic and rare. Some of the physics that are being written by Leonard Susskind and others are showing that actually wormholes may be very much part of our daily life and is involved in the way matter behaves. For instance, matter that is entangled, so 2 particles that are very far apart from each other, we know in physics and quantum theory and from experiment that if you modify one, if they're entangled, the other one is modified instantaneously, like there was no separation between the two, no matter how far they are from each other. Even if they're farther than the information could go across at the speed of light, they still modify instantaneously, because in fact space-time is folded in that region by a wormhole, and that's how they're connected. And that's very recent that the mainstream has come to those conclusions. Those are conclusions I came to almost 25 years ago. So I'm really excited that finally, it's entering the mainstream, and I think that in maybe a few generations, warp drives, meaning that not necessarily, yeah, I mean, in a few decades, we could have warp drives. That is very possible as soon as we have gravity control, which we're really approaching now. It's gonna be a question of, it's gonna be a question of much more like materials and our capacity to interact with, these kind of, forces and energy and so on. So of course, there's going to be a lot of developments that has to be made. But the possibility of curving space-time into a wormhole, I think, is totally viable. And in fact, I think it's right on our path. Are we going to get there on time? Society is on a self-destructive path right now. It has to.
That's right.
Yeah, and it has to change its tendency because I don't know if we're going to be able to get there on time. I'm a very optimistic person in general, and I have a feeling we're on a good track because I see a lot of changes. I see a lot of changes around the world, and some of the changes might be changes that we don't necessarily agree to. Like some of the presidents being, voted in, and so on.
Exactly.
But
bans, executive orders.
Right, exactly. But I think as well, those are catalysts for change. They're helping us like wake up and say what we want and say what we don't want. And be clear about it. And and maybe that will launch us into the new world.
That's actually really interesting that you brought that up. First, as you know, you just mentioned it, we have to get along with each other. And it might be what Reagan said, if we're faced with something or we meet some intelligent beings from another planet, then we will all come together as humans, as humanity, because we are all brothers and sisters. The difference of DNA between each other is so minuscule. It's crazy to have these wars. Now, I have a couple questions that people have been writing again. Now, I'm going to bring this up. The cars, okay? In the late 1800s, 19th century, we introduced the car. At first, I think there was the steam and some electric cars, but what really made it was the gas-powered the internal combustion engine. Now, here's the big problem I have. You have things like smartphones. Let's just take an Apple iPhone, for instance. You have more data or more things you can do on this globally than you could 15 years ago with a desktop computer. And so if that technology is moving so, at a rapid pace, why are we still going into space with 1,000-plus-year-old technology from the Chinese by burning chemicals?
Yes.
Right?
Yes, it's a good question, no doubt. And, you have to consider what we were talking about earlier, and that is the resistance to change of fundamental concepts. I think, to be honest, Dr. J, I think that we could have got there much earlier. Tesla was right on it. Tesla was very, very close to, or even may have produced this. We don't know because, like you said, we're missing a lot of information. But, he certainly was very close. There was others throughout history that were very close, all the way back to the Pythagorean schools. I believe the Pythagorean schools, 400 BC or so, were, very close to actually these drives being available, just because they had figured that there was a fundamental pattern. They knew it was there, They learned it from ancient civilization. That's a whole other story. But as well, they expanded on it with scientific method, and they got. I mean, they had strings oscillating and all this stuff, and I think if the Pythagorean schools, for instance, would not have been burned to the ground by the locals of the time, the mainstream of the time, I think humanity could have taken a completely different route, and maybe we would have had gravity control by now. I don't know. So yeah, evolution has to take its own path. At the time of Tesla, maybe it wasn't time for us to have that kind of stuff. Maybe we weren't evolved enough to have that kind of stuff. I mean, maybe the universe is a fail-safe place where if you don't have the right mentality and the right approach to the universe, then you don't get to play with the really, really powerful toys. You might be able to self-destruct, but you won't be able to, affect too much of the universe. You know what I'm saying? So maybe it was too early for us to have this, and maybe now it's the right time. As long as we get it before, our ecological issues get the best of ourselves.
And they really are. You're in Southern California at the moment, not Hawaii, right?
Correct. Yes.
Yeah. So you've seen it yourself. I remember when the rainy season started for the last 15 years, we were in a drought. We had reached California the same, or we had exceeded our rain minimum within a month. Mm-hmm. I think it was like 9 inches we're supposed to have, or 7. Mm-hmm. But now that, as of today, we have 9 inches more rainfall. So something is going on all over the world. You have the ice caps melting, which will affect the saline in the oceans, killing
the pH. Yes, absolutely.
Yeah. And then on top of that, try driving through Beijing. Well, you can't. You have to be in a taxi because that's one of their laws. Only residents can drive. But you're just going to see this enormous smog. So
right. I thought it was a interesting viral movie on the net right now with Mr. Terminator there.
Oh yes, Arnold. Yeah,
Arnold warning people about the health issues involved with smog and pollution, killing millions and millions of people, more than people in accidents and more than people in suicides or anything like that. And that California did a really good job at regularizing this. But the rest of the world needs to. But it's at a more fundamental level than that. We have issues, including of overpopulation. We have issues of just the pass of time. Let me explain what I mean by that. As an astrophysicist, you start to study, and you realize very quickly how many things can happen to a small planet like ours in the middle of this pretty intense solar system with solar wind flying at very high velocity, solar flares, comets coming by, meteorites coming by, and you realize how fragile our state of affair is. and I'm one of the people, including with alongside with Stephen Hawking and others, that are saying to the public, we have to get off this planet. We cannot just assume it's going to continue to stay in the same state, all the time. And so our achievement of gravitational control is critical to our survival, because we're not, like you were mentioning, gonna get off the planet on fossil fuel.
Mm-hmm. Exactly. We can't. What are you going to do? Build a giant rocket? And it's impossible. It won't
Right.
go. Anyway, has anyone ever tried to suppress you or, uh, say, keep you from, uh, I guess, I don't want to say attacking, but introducing these theories to people in the physics don't like it?
Oh, absolutely. Oh, absolutely. Of course. I have been very much censored. I've been censored in my capacity to publish. Systems that are available to all other physicists are not available to me for unknown reasons. Even if I pass peer review, even if I pass scrutiny, still it's not published. I've been segregated from certain conferences. I've been invited to very large and like very famous, I'm not going to name them, but very famous, like actually the most famous experimental institute. And so you guys can figure that out. And to present my theories, and then my talks have been censored, canceled by the directors of those laboratories. And so it's been a long journey. I try not to get frustrated. Of course, in the moments in which it happens, I get frustrated, but as well,
Who wouldn't? Oh, right?
yeah,
Who wouldn't?
it's been a long journey, 30 years. I'd like to be able to at least have my voice. I think I'm producing some information that's important, and many others feel that way. And as well, what's even more saddening is that some of the mainstream physicists that are out there have approached me and have agreed that what I'm doing is very valid and it's important that we look at it and all this. But when they go to their peers or they try to talk about it in their classes at university and so on, then typically, I mean, in many cases, they've been threatened of losing their employment or losing their tenure, and they get pushed away from their peers, or segregated from their peers and so on. And so it really it's a problem. It's not easy, and that's why although I get a lot of support, I mean, I get letters after letters of physicists saying I love your stuff.
Good.
They don't necessarily are not necessarily able in the structure of the institutions right now to publicly endorse it. So it's problematic.
But at least you're getting some physics backing you, as opposed to, like you said, 30 years ago. So, yeah, it's sad that they're trying to suppress you, but through programs like these, people can finally hear it, because we have all the networks, but we're not affiliated with mainstream media to censor us. Now, we have to follow FCC rules, so we can't curse or anything like that. However, we are bringing this information to the masses. Let me go back to time. This is something you mentioned, and I wanted to ask you earlier. Is time a man-made measure only, or is it universal?
Well, that's a good question. I would say off the bat that it is an emergent property of space-time, meaning that it is not fundamental. It is a concept of man. It is not a concept of universe. And I say that loosely. But what I mean is that without memory, there is no time. That is, if you cannot remember the second before, then you have no idea of a linear arrow of time or evolution for an instant. So actually, I just published, I'm excited about this, I just published a paper in biophysics. It's my first paper in biophysics. I published it with Mr. Brown that you've had on your show, and William Brown. And in this paper, I recoined from Einstein space-time to actually space memory. Actually, the title of the paper is Space Memory Network. And we eventually, from this structure of space-time, we describe the structure of the brain and how consciousness emerged in the structure of space-time as like a conscious being, like you and me, because that's an amazing thing. And if it's a true unified field theory, then it should explain that most fundamentally, because without us observing the universe, then we can't write physics on it. So we must be part of the equation, right? So this is a new concept of time, in which time, since there's evolution in the universe, then there's linear, relationship between things as well as nonlinear, and so they must be memory in space, meaning that we here we truly believe that we can't find memory inside the brain, because it's not inside the brain. The brain is just an antenna tapped into a field of information, and that field of information is specific to you because you fed it to the field, and that's what you call your memory. When you remember something, you're actually pulling information that's embedded, like a hard drive is holding information on your computer, and then the active memory of the computer goes and retrieves the information. That's kind of the way we describe it. And so basically, time is actually just information on the structure of space that's consequent, that is adjacent to each other, so that it looks like a linear arrow of evolution or time, right? And so it has structure. So it's like it's space memory or space information that makes the concept of time possible.
Yes. Quote from a movie, Lucy: time gives legitimacy to what we do. In fact, right? Isn't that the case? Okay, trying to go through these questions that people have been sending me. Anyhow, we're going to wrap soon, but let me get this to you. Okay, assume people have not understood the physics or anything like this, but have seen the movie Interstellar, where all of a sudden everyone's on a base, and I think, what is it, Venus or Jupiter or Saturn, I think it was. Yet you see children playing baseball, and their gravity is not really taking effect because there's homes, like sort of like a tunnel. Now, if you were to explain, assuming that people just hopped on the show right now, what in your mind could you portray as an image for people to see us traversing space, going to another system, or
how it would look on another world?
Yes. How would it look? How would it look in your mind? Again, this is just for the people who are new to this topic, as you know.
It comes from relativistic equation, from general relativity, where, in the large gravitational field, time would pass at a different rate. And so, they use that in the movie in a loose way to, in part of their story. So basically showing that time is not a constant thing. And we know that, for instance, clocks in planes run a little bit slower than time is on the surface. And so, we know that things, that time, since Einstein, we know that time and space are not like set in cement. They're flexible. That there's, dilation of time that can happen, or dilation of space that can happen. And that changes our relationship to it. So yeah, it is possible. What was portrayed there is based on the standard views, is definitely possible. And that's why it may be possible to jump into a black hole and come out on the other side of the universe through a wormhole. and
Yes.
and so and that possibility I concluded to very early on, and I started to actually think about how we would navigate this whole black hole wormhole thing and how we would make that happen.
Now, you mentioned a little bit ago that imagine us having antennas and you were comparing the human brain and memories, etc. Now, are you suggesting or can you confirm that every human being on this planet is capable of receiving more information?
Yes, I am saying that what we call, I don't know, some people call it IQ, level of intelligence, level of awareness. You may have many different words for it. What I'm saying is that, yeah, your biology can either, resonate more or less with the structure of the information that's in space-time. It's like an antenna that's either tuned properly or not tuned properly. Like if you have a radio set, like the old ones, I mean, you and I, we remember those, right?
Oh yeah, oh yeah.
And they had tubes, and in there was a crystal that was being oscillated, and when you would oscillate the crystal just at the right frequency, the same frequency of what was being transmitted, then you'd hear the radio, right?
That's right.
The listeners right now they're not on one of those radios unless they have an old one.
That's right.
Right, but it's a little different now, but it still involves oscillating crystals, but in a different way. But if you were to turn the dial on the radio set, these big old dials we had on the radio set, and you're trying to like tune the station, if you got off the frequency a little bit, then there'd be a lot of noise, right? So there was a lot of garbage, not much, you couldn't hear the music so good. And then you tuned that, and then all of a sudden it was crystal clear, you could hear the music really good. You can think about from the papers we just published, actually just touches on that Space Memory Network paper, which actually was just published at Neuroquantology, which is a very good journal. I'm pretty happy with this, and it's a mainstream journal. And when we're describing you as an antenna, more than consciousness being something that you're producing inside yourself, that you're tapping into a field of information, that means that truly you can tune your antenna to receive more information or less information. How much noise is in your radio set, right?
Yeah, that's right.
And so of course, like, how do you tune the antenna in the case of a human? You don't have no dials, that you can just turn the dial till you get the right station. Well, the dial in your case is maybe your state of emotion, what you eat, how you behave, how what you do with your body every day. Is it exercising? Is it not exercising? Think of your heartbeat and your lungs and all this. It's all breathing in and out. Think of that as an oscillation of a resonator, right? An antenna is a resonator. A radio is a sync circuit. It's a resonating circuit. So imagine that. Like, can you tune the whole thing to be more in resonance so you can get more information? I think so, absolutely. And I think that even the hard drive space in our body is there. We call it junk DNA, but I think that actually all the information, all we have, all we need to get more information is already present. We just got to turn it on.
I'm actually really, really glad you said this, because this is a topic that has come up a few times in the last 2 years. A lot of people talk about Akashic records, universal wisdom, etc., etc. But what if, like you said, it's encoded in our DNA? Now, I'm going to give everybody out there listening an example. Let's just say uh, your father's mother's grandfather, so on and so forth, had this experience, well, that DNA gets passed down to you. So what happens when you activate it? You will be able to see the experiences. At least that's the theory that I've been hearing about a lot. And you actually touched on it. I think that's fantastic.
Yeah, I like to think of DNA a little bit differently, and certainly microtubules. But instead of thinking that it's encoded on the DNA, I think of it as more that the DNA is like tuned in to a set of information that's encoded on space-time itself, like the complexity of, for instance, the gene that makes up your configuration is extremely high and cannot be contained just only in the biology of your body, although the biology of your body is a remarkable, extraordinary thing. Like, people don't realize 100 trillion cells that are like, creating something like billions of chemical change every second it's a non-trivial carnal engine. It is going hard, and it's going hard every minute, because if it gets a little confused, even for a few minutes, it wouldn't be good. You wouldn't like the result. And so it's highly coherent, it's highly organized, and what we're saying, it's not happening at the biological level. It's actually because each 100 trillion cell that you're made of is made out of 100 trillion atoms. That complexity is way higher. And the information present there, as we're showing with these new theories, showing that matter is actually a result of the information in space. We're showing that the information in space is what you're actually calling your consciousness, and it's flowing through your body.
Yes.
And so it's really where DNA and the structure of, it's called the structure of the microtubules, and the the structure of the brain, and the structure of the way your bone structure is made, the skin, everything, the connective tissue, and all this is oscillating and tapping in a very specific set of information that produce that organization in the first place. Because there's nothing in physics today or in biological theory that explain how such complex system can emerge from a supposedly completely random universe.
Correct. And random universe that had no oxygen, and then started with single cells to complex, organisms and biological organisms that are there. I don't know how many there are, hundreds of millions of species. It's just it's hard to fathom when you think about that.
Right. It's hard to fathom in just thinking about it, but it actually doesn't add up when you calculate it. And we made those calculations in that paper we just published, showing this, the probability, even for the most simple, form of life, the most simple, form of organization to occur is completely exceeds, the time our universe has been around by billions, trillions of years. And it doesn't, and even if the universe was way older than we were, the probabilities that this, that we think it is, like even if the universe is way older than what we think it is, the probability of anything like that, even making it between, from very simple interactions, which, our calculations show, I think, 10 to the 8,896, something like that, just for the fundamental base pairs to actually find each other and for something to happen in a random universe. That's a huge number. I think it's the biggest number I've ever seen in physics.
I don't think I could even
fathom.
calculate. Yeah.
I know.
Beyond.
Well, yeah. I mean, when a centimeter is short, right? Well,
Yeah.
and the universe is big, right? Well, the radius of the universe is approximately 10 to the 28 centimeters. So 10 to the 28 is a huge number, right? It's got all these zeros. Well, imagine.
Oh yeah.
And it's exponential. So imagine 10 to the 8,000. I mean, it's anyway. So
yeah, you're right. It's just how are you going to put 8,000 zeros after 9,000 zeros after a one? I mean,
right.
it is really hard to understand and fathom.
So it really is kind of like clear that there must be some kind of information feedback as well, so that like things are self-organizing because they actually have feedback from the local environment. This is what we see in nature everywhere. We see plants and animals and so adapt to their local environment because they get feedback from the local environment. They feel there is sensory systems that are feeling what's going on and that are modifying the way the biology develops so it adapts to the local environment. Well, if you have feedback, all of a sudden, all these calculations all go very directly the other direction, where things happen very, very, very rapidly, like fractal systems, where organization happen in a very short amount of time and changes happen in a very short amount of time. I mean, cosmologically speaking, right? Where life could develop on many, many planets all around the universe very rapidly because it's basically the hard drive of the universe is learning about itself. And, because it's learning about itself, it gets more and more complex and more advanced.
Exactly. And speaking of the universe, this is just something that goes against everybody except for people who are open-minded. Why would the universe continue to grow at a faster rate rather than slowing down?
Correct. That is a counterintuitive thing. If we think that the universe is only entropic, right? Entropic meaning that it goes towards further and further disorder, then it should be slowing down. Absolutely, it should not be accelerating. And that was the assumption until they were able to measure, some of the redshift of certain, entities in our universe and see that they were accelerating away from each other. And so showing that the universe is expanding and accelerating, not slowing down. So yeah, this can lead to a whole other subject, Dr. J, that has to do with negentropy, which is involved with gravity control as well, which means that there's not just an entropic side to the universe, but there's a negentropic side to the universe.
Exactly. And people have to remember that positive and negative. I mean, this goes all the way back to everything, good versus evil, it's just
polarity.
Polar opposites. Polarity. Thank you. That's the key word I was looking for.
Right. I mean, now, if things go towards further disorder, that means that there was order prior to that.
Yes.
So how did it get there, right? You can't just ignore that part. You can't just look at the disorder and say everything goes towards disorder. Because of course there was order before if it went towards disorder. So, and then when you observe the natural world all around you, if you see high level of complexity, high level of order, then there's something in the universe that's doing the contrary to entropy. There's something that's going towards negentropy.
Agreed. Very much agreed. Now, I know we're coming close on time, so a couple things before I get your final statement, which will be literally near the end in your plugins. I want to ask you, is there any other theory that you are currently working on but haven't divulged yet, or are you just expanding and confirming your theories and turning them into fact?
Yes, there's much more that I haven't been able to publish yet, and that I'm continuously working on. In fact, in the next 2 weeks, I'm going to receive 3 physicists here from different places around the world, and we're going to sit down and go at it for 2 weeks straight and work out some of the math for some of these. There's a core idea to my theories, but of course there's many things, details, like for instance, application to cosmology, applications to quantum physics, to quantum mechanics, to
our mind, right? Even to how we think.
To consciousness study, to biology and all this. So there's a lot more, and there's continuous research being done, absolutely. And I wish I could get it out as fast as I, get it into my little vortex of information that I call my brain. But it takes a while to write all these papers and flesh out all the math,
yes.
and and to confirm. And that's a great thing about math, is that math can help you, lead you from a fundamental principle into understanding the details more and more, and it kind of like does its own thing, and it's great. The error that has happened earlier in science is that the thought that you could just write math and it would show you the way is incorrect. You have to have a fundamental principle, because you can get math to say pretty well what you want. And that, I think, was one of the biggest error in string theory. As well, if you see the math is getting completely outrageous and complex, then you probably missed a turn somewhere. And you should look back and look for a simpler solution. And if there is one, then it's probably most likely the correct one.
Agreed. Now, let me ask you this before we start to wrap up, because it's very important. You touched on it a couple times, especially just now, and it's an important part of your training in the academy, the Resonance Academy, which all falls under the umbrella of the Resonance Science Foundation, right?
Right.
Now, let's talk about the importance of consciousness.
Right. Well, that's very good. There's a lot of talk about that. Dr. J, when I was saying earlier that it's great to see the opening that's happening even in the world of science. This is a good example. When I started presenting my ideas in physics in the late 80s, early 90s, if you pronounce the word consciousness, it was known as the bad C word, in a physics conference, you'd be in big trouble. But now, in the last maybe 10 years, it has been more and more popular for physicists to explore what is consciousness. And, it's really exciting, because there are many amazing papers being published. And we're starting to see, I think, a very formal description and understanding at a very deep level of the concept of consciousness. That is, that consciousness is not an epiphenomena of your brain kind of hallucinating this world, but it is actually your brain and your body, your whole body, all of your cells, expressing a relationship to a set of information that's in space-time itself. So consciousness in that case is not isolated to human beings, but consciousness is the whole thing, like the whole universe is striving, is putting all the elements together for you at the end to be able to turn around and say, who am I? Meaning
yes.
that the whole thing is consciousness learning about itself. Like without the planet, you and us wouldn't be here. You know,
Correct.
like all the trees wouldn't be there, the grass wouldn't be there, the food, the air. I mean, like the whole thing. If we wouldn't, you know, so like none of like all these elements had to be in place. So you can't just look at the complexity of a human being to like try to understand negentropy. You got to look at all the things that made it possible for that thing, that organization to even get there in the first place. So then you can't segregate. So you have to go back all the way to the production of matter and the structure of space-time and all this. And then you realize that is where the organization come from. So that is where consciousness lies. And so what is consciousness? Because we say consciousness is very loosely used. Well,
Yes.
okay,
Yes.
so let's try to define it a little bit. Consciousness, we're talking about self-awareness. That means you know self, right?
Introspection, right?
Introspection, exactly. You see yourself in the mirror, you know it's you, and you're able to have cognitive function based on this. Well, okay, that in space-time just looks like feedback, meaning that there's information going out and it's changing the information in the field so that there's a very specific set of information coming back in. And so that there's like a feedback of information continuously going on that's informing the rest of the universe, that's informing everything else of what's going on, so that everything is actually coherent and coordinated, that when you reach for the mouse on your computer, it's still there. It's not, you know, it's not in a completely different space-time, but it's interact.
That's right.
And so, yeah. And we know that from quantum theory. We know that the observer is influencing the field. It's just not being described formally in quantum theory appropriately, meaning like the theories of quantum theory being incomplete in themselves didn't allow for an appropriate description of consciousness in it.
And I think that is one of the most important things, because for millennia, I think, or unless they knew more then and somehow it got suppressed with these gadgets and stuff from the revolutionary era to now, but literally the first time I really saw something of someone promoting consciousness was with when he came back from the moon, Dr. Edgar Mitchell, sixth man on the moon,
right?
Apollo 14 astronaut. He studied or founded the Noetic Sciences Organization.
Yeah.
Institute, yeah, all about consciousness. And everybody is starting, well, not everybody, but a lot of the guests on these topics are now realizing how important consciousness plays its role in humanity.
Exactly, of course. And, you know, it really is critical that we understand the mechanics that makes that happen very fundamentally, so that we actually understand how we got here and what we're participating in. Imagine, all of a sudden we're realizing we're not just like, you know, like couch potato observers watching the universe go by. We're participating in it, and we're participating in the reality that's being presented, and but not in a way in which we impose our participation, but we're collaborating with, you know, the whole. We are part of something much larger that we are interacting with, and it's an amazing thing to discover.
Agreed. Now, let me ask you this, because we have to wind down. Before I get your final statement, is there any other topic that we haven't touched on that you may want to touch on briefly?
I think that, you know, if for the listeners, you know, for them in their daily life, you know, when they hear all this, they go, okay, well, how is it that I can, you know, benefit from this in my daily life? Because it sounds very, you know, out there and complex and scientific and, esoteric and so on. Well, I think that it's important for the listeners to know that, like, um, they're part of that feedback right now, and they can tune their radio set, as I was discussing earlier, and that uh, introspection, like being able to increase how much you understand yourself by looking into yourself, even, if it's just studying how much cells you're made of and trying to feel them, trying to feel what you're made of, and then trying to feel all the atoms you're made of. And, some people might call that contemplation, meditation, whatever, prayers, people might call it all kinds of things. But if you actually take the time of, instead of being distracted outside yourself all the time, if you take a few minutes a day to just do this turning of your senses inwards, I think it has great benefits. And I think that's one of the benefits of understanding these theories is you understand that these concepts are not just spiritual concepts, but they're actually physics concepts that have been, I always say spirituality is the physics we haven't understood yet. Because if it's real, that means it has physics attached to it.
That's right. That's right. And I think they are interlocked, just as you said, and most people are starting to finally come to the realization, because it's there's so much importance to it that, like I said earlier, people weren't even paying attention. They were looking at just the nuts and bolts of things. Well, just hold on a second. Have some introspection so you can understand who you are. That way you could absorb more and listen more and see more and wake up. That's what I would say. Wake up. Disclosure is in your hands. Mr. Harriman,
yes.
If you could give, I know you gave a statement, but if there's anything else you want to tell the people, not to mention plug in, of course, the Academy again.
Right.
Please do so.
I really would love for people to participate in the Academy or become a member of the Resonance Science Foundation, because it is really connecting a network of people all around the world, and what we are learning together is remarkable, and how we're able to progress together and grow together is fantastic. And of course, there is the Connected Universe movie that just came out from Malcolm Carter that describes my theory in layman with amazing visuals. Malcolm Carter did an amazing job at representing, what can be a little bit complex in very simple and beautiful ways in this movie. So we're really excited about that. That was narrated by Patrick Stewart too, which it was great to have Captain Picard narrate, this new view of the universe, because if he can, he's qualified to lead us where no one has been before, and so
that's right.
and so it's great. It's out there, you can get it on Vimeo, and it really is a powerful movie. I'm really we had a premiere in LA, we had a premiere in Paris and in London. Many stars were there. It's really exciting. So that's another thing people can participate in.
That's right. Everybody, you heard him. Make sure you check that out.
There is amazing things happening in the world, and it's hard sometimes to see past the trees when you're in the forest, because when you see, you miss it, the trees for the forest, because there's so much negative stuff happening out there, but there is amazing stuff happening as well. And being part of this community really kind of allows you to flourish and blossom and express yourself. And as well, what I would like to leave people on is that there's a lot of hope. There's a lot of possibility. There's a lot of hope. And at this point, we have to pull together, and we have to become, a force in the world. and that will make the change, that because we are making the change for ourselves individually, and the result is that we're feeding back to the structure of space-time the change we want to see in the world. And so it's really it demands a commitment, but it's a wonderful journey. And I think people, if we've opened those channels at the Resonance Academy so that people would have all the information they need to embark on the journey.
And again, everybody, I vouch for the Academy because I am going through the Academy as we speak. And as you heard Mr. Herman talking, children can go through this. Anybody can go through this, and it will make you a better person and be able to know more about yourself and understand these theories, which will soon become. Now, our promos, of course, you guys, everybody, if you caught very late, you're listening to the one and only Dr. J Radio Live, broadcasting from the City of the Angels internationally, 48 countries and counting. I also want to thank, of course, Johnny Webb, my co-host in the UK in London, who could not make it here today, but he's an integral part of the team, as is Tom Schaefer, a webmaster and a production engineer, and not to mention Lucian, and all the several volunteers. Also, remember that you have several ways to hear the show. First of all, check your local listings. If you are in the Midwest, you would find it in some FM and AM stations. Also, don't forget that you could listen directly off the site, which will have some visuals too to make it as an MP4. That way you guys will get some eye candy seeing Mr. Herman and some of these concepts being shown. And also the networks. Of course, you're hearing right now on our very own Coast to Coast PM radio network, not to be confused with the AM show. We're PM network. And we are syndicated with Late Night in the Midlands, as well as PSN Radio. Both of those are in the United States. Not to mention Deprogrammed Radio and Pulse Talk Radio in the United Kingdom. And we are currently talking to a Spanish. I'm not talking about Latin America in North or South America. I'm talking about from Spain. A station in Spain has approached us to carry the show, as has an Australian station. So I want everybody to check those out. And of course, you can go to iTunes, Shoutcast, or TuneIn.com, and there's more coming. And remember, folks, there's only one word you need to remember. That is the name of the show, Dr. J Radio Live. That is drjradiolive.com is the website. For Facebook, YouTube, Instagram, Twitter, Flickr, Tumblr, Slack, Snapchat, things I don't even know. They're all under the same name. Reddit even. DRJ Radio Live. And now I am officially signing off.
What a fantastic interview, folks. Wow. Right from the mind of Mr. Nassim Haramein, futurist, cosmologist, and more importantly, the physicist who has a vision. Please, everybody, make sure you check out the Resonance Science Foundation. Take the Academy course, the Resonance Academy. All of it can be done by going to our website, drjradiolive.com, and clicking on his banner. Not to mention, go directly to his website, which is resonance.is, resonance.is, is as an institute. Again, what a fabulous interview. I apologize for all those folks who've been writing questions throughout the entire show. We could not get them, but this is what I promise everybody, literally from all four corners of the globe, that next time he comes on, just like I did with this show, I will select the questions that are asked by multiple people, multiple times, and then I will ask them directly to Mr. Herman, unless, of course, he was able to join us and take calls that night. In the meantime, watch for this show to be rebroadcast on other networks, and then, of course, it will hit YouTube under, what did I say earlier? Dr. J Radio Live. Again, everybody, from the mind of Nassim Haramein, make sure you check out his movie, take the Academy course, look at resonance.is, look at the foundation, and, of course, you can see him in person at several events and laboratories that he opens. With that being said, now this is the time I officially want to sign out. I just wanted to acknowledge Nassim for being a man who's standing up against what the mainstream does not want us to know and empowering you with the knowledge. Because, like I said, through the show, knowledge is power. What you do with that knowledge is up to you. But whatever it is, you can never go wrong with having more knowledge. That's it, folks.